Hey guys, welcome back. This is lesson 2, and it's about linear functions. We did lots of things with linear functions, but one of the things that we did was we wrote equations given certain pieces of information. So that's what we're going to look at in this lesson. Remember, there's two forms that we went over with linear functions. One was slope-intercept form, one was point-slope form. Point slope form, remember the y sub 1 and x sub 1, that stands for a point that you know. So x sub 1 is the x coordinate, y sub 1 is the y coordinate of a point that's given to you. And on both forms, remember m was the slope. So if you look at example number 1, we want to write an equation in slope-intercept form. But it just depends on what information is given to you. If you want to write something in slope-intercept form, you got to know the slope and the y-intercept. Well, for this particular example, we don't know the y-intercept, but we do know a point and the slope. Whenever you're given a point and a slope, we always want to use point-slope form. Then we can convert that, remember, into slope-intercept form. So if we start with point slope, we're going to have y minus the y coordinate of the point is -4. So y minus -4 equals slope 8/3 times x minus the x coordinate of the point is -3. And then on both of these, minus a -4 and minus -3, minus a negative just turns into plus. So there's our equation in point slope form. Now to convert this into slope intercept, distribute. And then 8/3 times 3. 3 is a fractions, 3/1, and the 3's cancel out, so you're left with 8/1, which is just 8. And then the only thing to do to get it into our slope-intercept form is we need to get y by itself. So I'm going to subtract 4. And we have our equation in slope-intercept form. So there's our equation that goes through that point and has that slope. Okay, example 2. Same thing, we're going to write an equation slope-intercept form. To start with slope-intercept form, we need to know the y-intercept. That's what b is. That is not the y-intercept, and that is not the y-intercept. So the first thing we're going to do if you're given 2 points is you need to find out what the slope between those 2 points are. So remember slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Change in y over change in x. So y sub 2, second y coordinate is -5, minus y sub 1, the first y coordinate's 2, over x sub 2, the second x coordinate is 4, minus x sub 1, the first x coordinate is 2. So on top we'll get -7, on bottom we'll get 2. So there's our slope. So now we know the slope. Pick one of these points and do exactly what we now did up here with example 1. So that one looks like the easier point to use. I'm going to use the first point. Start with point slope y minus y coordinate equals slope times x minus the x coordinate of that point is 2. Distribute. So we get -7/2 x. Negative times a negative is a positive, and 7/2 times 2 2's cancel out. You're left with 7 over 1, which is 7. Last step to get y by itself would be to add 2. And we end up with y equals negative 7 halves x plus 9. There's our equation that goes through those 2 points in slope-intercept form. All right, last 2 examples deal with parallel and perpendicular lines. If lines are parallel, then their slopes have to be the same. So if we want an equation of a line going through those or that point and is parallel to this equation, well, if we know it's parallel to this equation, we want to use the same slope. So I want it to go through this point and have the same slope as the line that's given to us. So again, start with point slope. Y minus negative 5 is going to turn into plus 5 there, equals slope times x minus the x coordinate is 4. Again, we want our slope intercept, so now we're going to distribute. And negative times a negative is a positive. 1/4 times 4 is 1. Subtract 5. And we will end up with our equation in slope-intercept form. So there's our equation in slope-intercept form that's parallel to this and goes through that point. All right, last one, perpendicular lines. So perpendicular, remember, intersect each other at 90-degree angles. So one thing we know about perpendicular slopes is they are opposite and reciprocals. So if I want to create a line that goes through this point and is perpendicular to this line, we need to find out the opposite reciprocal of this slope. Opposite is going to be positive. And then the reciprocal of our fraction here is 7/4. So the opposite reciprocal would be positive 7/4 to this slope. Passing through that point, so we're going to start with point slope again. Y minus the y coordinate, so that turns into plus 2, equals 7/4 times x minus the x coordinate, that turns into plus 4 then. Distribute. And then 7/4 times 4 would give us 7. Subtract 2, and we will have our equation. So there's our equation that is perpendicular to this line and passes through that point. All right, I think you should be ready for the worksheet at this point.